So hello and welcome guys. Today we will solve another problem based on prestressed concrete. Here is the question. A rectangular concrete beam of cross section 30 cm depth, 20 cm width is prestressed by means of 15 wires of 5 mm dia located 6.5 cm from the bottom of the beam and 3 wires of 5 mm dia 2.5 cm from the top. Assuming the prestress is in the steel is 840 kN per meter square. So now calculate the stresses at the extreme fiber of mid-span section when the beam is supported its own weight over a span of 6 meter. If a uniformly distributed load of 6 kN per meter is imposed, evaluate the maximum working stress. In concrete, the density of concrete is 24 kN per meter cube. In the given question, they asked to calculate stresses at the extreme fiber of the mid-span, means we have to calculate resultant stress. And this is the diagram. 200 mm with 300 mm depth, and here is the 15 numbers of wires at a distance of 65 from the bottom, and here is the 3 number of wires at a distance of 25 mm from the top, and y value up to this is the live load given, and this is the length of the beam. Eccentricity is the from the center to the y value, that is E. B given 200 mm, D given 300 mm, live load given 6 kN per meter. Now for calculating resultant stress, we have to calculate direct stress, that is P by A, bending stress, that is PE by Z, dead load stress, that is mg by z, and live load stress, that is m suffix q by z. Direct stress. P by A. We don't know the value of P, but in the question stress is given 840. We know the stress is equal to force by area, that's force we have to calculate, and the area of the wires. So pi by 4 into 5 square into total number of wires 18. So here P value is 3 into 10 to the power 5 Newton, and A is the cross section area, B into D, that is 6 into 10 to the power 4 mm square. So put the value into 10 to the power 5 divided by 6 into 10 to the power 4. So 5 Newton per mm square. Now we know the value of P, but we don't know the value of E. So for calculating E, we have to calculate Y value. Y equal to CC distance of prestressing force from the bottom. So number of wires into distance 275 plus number of wires into distance from the 65 and the total number. E equal to d by 2 minus y, that is 150 minus 100 equal to 50 mm. Now z equal to I by y, so I will be bd cube by 12, that is 45 into 10 to the power 7 mm to the power 4. সুতরাং z will be 45 into 10 to the power 7 divided by y equal to 100, means z equal to 3 into 10 to the power 6 mm cube. Now let's solve for the third number, that is self weight stress, means dead load stress. mgz by z. mg will be dead load, mg will be wl square by 8, so here w will be the dead load of the beam, means 0.2 into 0.3 into 24 into L square 6 square, that is 8. So putting the value 6.48 into 10 to the power 6 divided by z, 3 into 10 to the power 6, the value of 2.16 Newton per mm square is the last point, fourth number, live load stress. mq will be wl square by 8, w will be the live load. Live load is given 6 kilonewton into L square 6 square divided by 8. It is 27 kilonewton meter, 27 into 10 to the power 6 Newton. So put the value 27 into 10 to the power 6 by 3 into 10 to the power 6, that is 9 Newton per mm square. And now the resultant stress due to self-weight pre-stress live load are shown in the figure. So we put here the direct stress. This is the actually direct stress. we put here bending stress, the figure for the bending stress, and we put here self weight stress value and the live load stress value. And see, this is the positive, they are negative, this is positive, this is positive, and sum of all we got the resultant value 11.16 Newton per mm square. And here is the positive, this is positive, this is positive, this is negative, this is also negative, and we got resultant stress at the bottom. This is the actually answer of our question.